Hello, and welcome to our first IWMF Global Educational Webinar for 2024. I'm Peter Donardis, IWMF Chair of the Board, and I was diagnosed with Waldenstrom's in 2003. And this topic today is of particular interest to me because I have a sister who has CLL, and my father passed away from multiple myeloma. So today we'll be having a 1-hour presentation titled Familial WM Research from the Frontlines, which will cover information about familial research being conducted at the Mayo Clinic in Rochester, Minnesota. Our speaker for today is Dr. Susan Slager. Dr. Slager investigates the inherited genetic basis of lymphoma, including CLL, chronic lymphocytic leukemia, non-Hodgkin's lymphoma, multiple myeloma, and Hodgkin's lymphoma. Dr. Slager leads the Mayo Clinic B-cell lymphoma family registry, in which more than 500 families, including relatives, have consented to participate. These families are followed over time to better understand why relatives from these families have a higher risk of lymphoma, regardless of lymphoma subtype, than the general population. At the end of the presentation, we will leave some time for questions. On your screen, you'll see a questions and answer tab to submit your questions, as well as a handout tab for program resources. I'm now going to turn the program over to our speaker. Thank you for joining us today, Dr. Slager.
Thank you, everyone. I am honored to be invited to give this talk and be the first one for the 2024 year. So I'm assuming everyone can see my slides now. So I'm going to be talking about the family study of Waldenstrom's that we have here at Mayo and what we're doing. Let's see here, next. Okay, so first, I don't have any financial conflicts or disclosures. The other thing I want to bring out is some of the results presented today are new results and have not yet undergone scientific peer review. So Waldenstrom's macroglobulinemia, or WM is the acronym, is a rare lymphoid malignancy. And so what I show here, I got to use the pointer. What I show here is an incidence rate of Waldenstrom's. And so this is from the Surveillance Epidemiology and End Results, or the SEER, which is funded by the National Cancer Institute here in the United States. And what they're finding is that the incidence of Waldenstrom's, so out of 1 million individuals, just over 3.6 individuals would be newly diagnosed with Waldenstrom's. So it's a very rare malignancy. And you can see the incidence does vary by race and ethnicity. So what do we know about the risk factors of Waldenstrom's? One of the more prominent ones is the genetic predisposition, what you get inherited from your family. And so here I have what is known for many, many years is that a family history of Waldenstrom's or a family history of any other lymphomas increases your risk of getting Waldenstrom's. And so here's just a figure of a family. It's not any particular family that I've enrolled in my study. But what I have is the mother is in red here and the father is this square. And they have 4 offspring. One of the children has CLL, or chronic lymphocytic leukemia, which is another lymphoid malignancy. And then another offspring has Waldenstrom, and another one has Waldenstrom's, and their 4th child doesn't have any hematologic malignancy at the time that we ascertain this pedigree. And so, oh, that does work. Okay, and so one of the largest studies to look at the familial risk of hematologic malignancies, including Waldenstrom's, was conducted by Ahmet Sud back in 2019. And what the authors did is they used the Swedish Cancer Registry and the Swedish Family Registry to look at these familial risks across hematological malignancies. Hematologic malignancies include lymphoid malignancies, such as Waldenstrom's, and the myeloid leukemias as well. And so using this cancer registry in Sweden. So every newly diagnosed cancer in Sweden gets reported in this cancer database. They identified just under 2,000 individuals with Waldenstrom's from this cancer registry. And next, what's unique to Sweden is that they have a family registry where they know who's all related to whom. And so that using these 2,000 patients with Waldenström's, they were able to identify all their first-degree relatives. So here they have just over 6,600 relatives of these Waldenström's patients. Then among these relatives, they went back to the cancer database to see who had a hematological malignancy. So using this information, they were able to determine their familial risks. And so for what they found for Waldenström's is that patients, first-degree relatives of patients with Waldenström's have a 16-fold increased risk of Waldenström's. And if you look at this figure on the right, here are the lymphoid malignancies that the patient has, and here's the lymphoid malignancies that the relative could get. And so Waldenström's falls in this lymphoplastic lymphoma here, it's lumped in there. And you can see when a color is bright red, they have a 4-fold increased risk of that malignancy. And then when it's a slightly yellow, then it's just above 1 increased risk of getting malignancy. A value of 1 means no association or no increased risk. And what you can see for people with Waldenström's, the familial risk, if you had a first-degree relative, their familial risk for Waldenström's is going to be over 16-fold. That's what I show down here. But relatives of Waldenström's patients also have an increased risk of getting mantle cell lymphoma, small lymphocytic lymphoma, chronic lymphocytic leukemia, which is another lymphoid malignancy. They also have an increased risk of getting Hodgkin's lymphoma. So it's not just Waldenström's that they have an increased risk, it's these other B-cell lymphoid malignancies. Let's see. It's not going forward. Oh, there we go. Okay. So if we go back to this pedigree that I showed you, what's the risk of getting Waldenström's for this particular individual that has yet no Waldenström's or no cancer or hematological cancer? So based on that study from Amit Sud and all, what they're finding is that they had a 16-fold increased risk of getting Waldenström's. And as I mentioned, this individual also has an increased risk of getting chronic lymphocytic leukemia or a subtype of Hodgkin's lymphoma. So because of this familial risk that's been known for many years, we started the Mayo Clinic family study of lymphoid malignancies. We started this back in 2004 is when we started collecting families. And families are eligible if they have 2 or more members with a lymphoid malignancy. And what I mean a lymphoid is it could be a Waldenström's or chronic lymphocytic leukemia, Hodgkin's lymphoma, non-Hodgkin's lymphoma. So here's a pedigree, an actual pedigree that enrolled in our study. This pedigree consented back in 2005. So the patient that brought this pedigree to our attention is the individual here. They either came to Mayo Clinic in Rochester, Minnesota, or they reached out to us to say they're interested in participating. So this individual does have Waldenström's. And then next we would try to consent all the first-degree relatives of this individual to ask them to participate. So 2 of the siblings agreed to participate, and their offspring, their child, also agreed to participate in our study. We would also invite individuals with any lymphoid malignancy. And so this individual is the uncle of this patient here. You can see that is that you follow this line over, and these are the parents. Here's the dad, here's the mom. And then if you follow this line up, these are the siblings of this individual. And so this is the father of this individual, and so this is the uncle. So the uncle has Waldenström's. The father, who is deceased, had CLL. The father also had another brother with a lymphoid malignancy, CLL, and this person had lung cancer when we reported this family. And so you can see that this family does have multiple members with a lymphoid malignancy. 2 of them have Waldenström's, and 2 of them had chronic lymphocytic leukemia. Here's another pedigree that we enrolled back in 2015. Again, this is the individual who came to the clinic or reached out to us about participating. They had Waldenstrom's. We tried to consent as many first-degree relatives as we can. These two individuals, at the time that we consented them, did not have any hematological malignancy, but you can see in this pedigree, this is the individual. Their father had Hodgkin's lymphoma, and then you follow this line up. This is the grandfather. They had chronic lymphocytic leukemia, but they were deceased before they can be enrolled into the study. So we use these family members to help identify inherited genetic factors for risk of Waldenstrom's or other lymphoid malignancies. And so one of the ways we do this to find these inherited factors is we use a genome-wide association study, or GWAS for short. These genome-wide association studies are an agnostic approach to identify common genomic positions associated with risk of Waldenstrom's. And you genotype a large number of genetic markers across the genome. And what I mean by genetic markers is that you can assume that these genetic markers are like mile markers that you see on the interstate. And these markers mark a region in the DNA. So you ultimately get kind of this map of the genetic markers that we know where they are in the DNA, and you get it mapped along the whole genome. So with these genetic markers, we genotype a large cohort of individuals with our cancer of interest, in this case Waldenstrom's, and then we have a collection of individuals that don't have Waldenstrom's, which we call controls. And you compare these genetic markers, the frequency of the genetic markers between the individuals with Waldenstrom's compared to the individuals without Waldenstrom's. So I'm going to step back and talk about what we've been doing for chronic lymphocytic leukemia, or CLL. It's another lymphoid malignancy, as an example of where we're going for Waldenstrom's. The reason I'm doing that is because CLL is 15 times more common than Waldenstrom's, and therefore the research is a little bit further along or more advanced than what we have for Waldenstrom's. And then once I'm done with CLL, I'll jump back to what we've been doing for Waldenstrom's. So starting in 2008, we started up the first CLL GWAS was published. And then subsequently, a number of studies have been published where we're identifying inherited genetic factors, or these genetic markers, for risk of CLL. One of the most recent studies and the largest studies was conducted by the Interlymph Consortium, which I'm a member of. And this is a consortium of researchers like myself who are located in the United States, in Canada, predominantly in Europe. We have my colleague in Israel and even in Australia, where we come together to study risk factors for not only Waldenstrom's, but also the other lymphoid malignancies. So through the Interlymph Consortium, we've published the most recent paper for chronic lymphocytic leukemia back in 2017, where we had genotyped just over 4,400 individuals with CLL and then 13,000 individuals without CLL, or our controls. And what we have here in this figure is called a Manhattan plot. It's called a Manhattan plot because it kind of looks like the skyline of Manhattan. On the x-axis are the chromosome positions. You have the chromosome 1 all the way up to chromosome 22. What's missing here are the X and the Y chromosomes, also known as the sex chromosomes. We don't typically look at those, or they're just more difficult to look at. And so here we're looking at, on the y-axis is the significance of each of the variants, the genetic variants or the genetic markers. A value that's really high means it's highly statistically significant. A value below the dotted line means that we would not call it as a risk factor yet. It hasn't met our threshold for being called a genetic marker for risk of chronic lymphocytic leukemia. And what you note from this figure here is that across the whole genome here, we have genetic markers associated with risk of CLL. It's not located on any one chromosome, but it's across many of the chromosomes. Here's one of the more significant ones on chromosome 11. You can see each dot is a genetic marker, and there's a number of them in this region that are associated with risk of CLL. They're very correlated with each other, so they don't provide each one doesn't provide new information. And so usually we just take the most significant one in the region to represent the region. Here's another one on chromosome 2. There's quite a few genetic markers that are associated with risk of CLL for this region. And so to date, there are 42 genetic markers that have been associated with risk of CLL. Another thing to note about these genetic markers for risk of CLL is that they're also genetic markers for other lymphoid malignancies. So I want to highlight one on chromosome 6 here. So each one of these are a chromosome, and you can see on chromosome 6 here that this genetic marker for risk of CLL is also a genetic marker for Waldenstrom. It's the only one that overlaps at this time. Remember, Waldenstrom's is a rare cancer, and therefore we don't usually have enough patients to identify the genetic markers like we have for CLL, which is one of the more common lymphoid malignancies. Another region here to highlight on chromosome 6 is the HLA region, where it is a genetic marker for a number of the lymphoid malignancies, including diffuse large B-cell lymphoma, Hodgkin's lymphoma, mantle cell lymphoma. So these genetic markers that are risk for CLL as well as other lymphoid malignancies kind of supports what we see in the pedigrees, where here's one of the pedigrees I showed you in the beginning, where the family had not only individuals with Waldenstrom's in the family, but there was individuals with chronic lymphocytic leukemia in this family. So these genetic markers are not just markers for one lymphoid subtype, but seems to be markers for other lymphoid malignancies. So one thing to note about these genetic markers for risk of CLL is that they have a small effect. Each one of these, of the 42 genetic markers identified for CLL, has a really small effect for risk of CLL. If you remember what I said earlier about risk of Waldenstrom's, the familial risk, it was 16-fold. That is a really high elevated risk. But each of these genetic markers that have been identified for CLL has a small effect. It's 1.2, 1.3. These are very small effects. So each one of these has a very low prediction in getting the risk of CLL. So we thought next is if we can combine these genetic markers across all 42 of them, can we get a better predictor of risk of CLL? And this is what my postdoc Geffen Kleinstern, who's now at the Haifa University in Israel, has done for the genetic variants for risk of CLL. So here's a little math. So we in this combined score, it's called the polygenic risk score, or the PRS. And so here's the little math that I was going to do, is that now there are 42 genetic markers for risk of CLL. Each one of these markers, you can have 0, 1, or 2 copies of the risk allele. And you get 2 copies is when you inherited the risk allele from your mom and from your dad. If you only have 1 copy, you only got 1 copy from one of your parents. And if you have no copies, then you didn't inherit either of the risk alleles from your parents. And so we count up for each of these 42 variants how many copies of the risk allele that you have. And you weight them by the effect size that we got from the genome-wide association studies. So ultimately, you get a score for each person, the polygenic risk score. And when you look at the distribution of the polygenic risk score across a whole bunch of individuals, here we have 2 cohorts of controls, one from the inner lymph of almost 8,000 individuals. The other one is a set of controls from the Mayo Clinic. And you look at the distribution of the polygenic risk score across these 2 control groups, what you see is a remarkably similar distributions between these groups of individuals. Yet these individuals were collected from different institutions. They were genotyped from different companies, but yet we see very similar distributions of the polygenic risk score. The most common score is around 7.5 for both of these 2 control groups. Very few individuals in the control groups have scores greater than 10. Very few of the individuals have scores less than 4. Now, if you add the CLL patients to this, you can see the distribution in the CLL patients is shifted to the right, which means that they have more inherited variants that increase your risk of getting CLL than what you see in the control group here. And so this effect size actually has a 2.5-fold increased risk of getting CLL. It's highly statistically significant with a p-value of 10 to the 9.94. Usually a p-value of 0.04 or 0.05 is considered statistically significant. So this is highly significant for risk of getting CLL. But sometimes this continuous distribution is hard to interpret. So what we're going to do next is categorize it by quintiles. So we take the distribution that you see in the controls, the polygenic risk score that you see in the controls, and we break it up into 5 equal groups or quintiles. And in each group, there's 20% of the controls are identified in this region. Because this is the most common region, we use that as the reference group. That's the one that's most commonly seen among the controls. And we compare each of these other quintiles to the reference, to the middle quintile. And so when we do that, what we see here is that individuals who is in the highest quintile, so if your polygenic risk score falls in the highest quintile, the highest 20%, you have a 3.6-fold increased risk of getting CLL, highly significant. And you can see that about half of the CLL patients fall into the highest quintile. Whereas if you go into the lowest quintile, you have a protective effect. So if you were going to genotype all these 42 variants and create your polygenic risk score, and your score falls in this region, that means you actually are protective for getting risk of CLL. The reason why these 5% of individuals did get CLL must be due to something else that we're not sure, or it's not captured by the polygenic risk score. And that, like I said, there are 5% there. So next we wanted to see, how does the family history impact your polygenic risk score? And so if we go to we then break up our cohort of individuals that participated into those individuals who have a family history of lymphoid malignancy and those individuals who don't have a family history of lymphoid malignancy. So if we just focus on the CLL patients and the controls with a family history of lymphoid malignancy, and we look at the polygenic risk score, this is what we see. So if you have a polygenic risk score in the highest quintile, and you have a family history of lymphoid malignancy, you have almost a 7.6-fold increased risk of getting CLL. And about 57% of the CLL patients with a family history falls in this highest quintile. If your polygenic risk score falls into the lowest quintile and you have a family history, you again are protective against getting risk of CLL. Very few CLL patients with a family history fall into this group, just about 2%. But if you're family history negative, oops, I lost my cursor. It stopped. There we go. If you're family history negative, that means you have no family history of a lymphoid malignancy. Your risk of getting CLL is still elevated at a 3.3-fold increased risk if your polygenic risk score is in this highest quintile. If your polygenic risk score is in the lowest quintile, again, you're still protective against risk of CLL. So, should the polygenic risk score for CLL be used to screen individuals? Let's review kind of what I've been going through. So if you have a family history of lymphoid malignancy and you're this individual and you genotype these 42 genetic markers and you create the polygenic risk score, our data suggests that if you're in that highest quintile, you're going to have an over 5-fold increased risk of getting CLL. But if your polygenic risk score is in the lowest quintile, you're protective for getting risk. And in fact, you would be more likely of getting risk of a different lymphoid malignancy than getting the risk of CLL. But if you don't know your family history and you're in the general population and you go out and you get genetic testing for these 42 genetic markers and you create your polygenic risk score, If your score is in the highest quintile, you still have a significant increased risk of getting CLL at a 3.5-fold risk. But if your polygenic risk score is in the lowest quintile, you have a very low chance of getting CLL. Doesn't mean you won't, but it looks like you might be getting something else and not CLL. So in summary, for CLL, we have identified 42 genetic markers that are robustly associated with risk of CLL. And there's more to come as I talk about a little bit later. If you combine these 42 variants into a polygenic risk score, this polygenic risk score is significant for risk of CLL, and it's been validated across a number of studies. So the polygenic risk score could be used for screening, but I want to make sure that there's no preventive measures to prevent a person from getting CLL. So even if you did this genetic testing, there's nothing you can do about it. You would just be more informed about your risk of getting CLL. Doesn't mean if you're in the highest quintile, you'll get CLL. It just means you're at increased risk. So what about Waldenstrom's? Where are we at with Waldenstrom's? So back in 2018, my colleague Mary Lou McMasters and I and our colleagues from the Interlimb Consortium did perform a genome-wide association study for Waldenstrom patients and controls. We had just over 500 Waldenstrom's patients and over 4,300 controls that we had genotyped across the genome to look for genetic markers that increased your risk of Waldenstrom's. And we found 2 genetic markers that increased your risk of Waldenstrom's. The effect size of these genetic markers were really larger. They're effect size that I've never seen in my genetic research in 20 years. So one of them is located on chromosome 6, had an effect size of over 20. And if you remember for CLL, the effect sizes were 1.1, 1.3, 1.4, very small compared to what we see for Waldenstrom's. And the other position that we saw for Waldenstrom had an effect size of almost 5-fold increased risk. We did validate these effects in the study, so we did confirm that they were real. I want to make sure that you know that these genetic variants, if you test them, it doesn't mean you will get Waldenstrom's. It just means you have an increased risk of getting Waldenstrom's. So this is the novel results that I wanted to present that haven't been published. This is through the Interlimb Consortium again, where we have been collecting since our 2018 paper, we've been collecting new patients, Waldenstrom's patients, and controls to perform a new genome-wide association studies across the lymphoid malignancies. And so here you can see the lymphoid malignancies that we've been looking at, including chronic lymphocytic leukemia, and then the Waldenstrom's here, and then as well as other marginal zone, diffuse large B-cell, follicular Hodgkin's, and so on. And so for Waldenstrom's, this is what we previously published. We had 223 cases in the prior Waldenstrom's GWAS, plus our familial cases that were not included here. And now, since 2018, we've been able to consent individuals. 1,400 Waldenstrom patients have agreed to consent for these genetic studies, and over 55,000 controls were identified to participate in the study. So between what we've previously done and what we've done since 2018, we now have almost over 1,600 Waldenstrom patients that are participating and 59,000 controls. So we've done a new genome-wide association studies, and this is what we found this is the new Manhattan plot, where again we have the chromosome positions from 1 to 22, leaving out the sex chromosomes here. The y-axis is the statistical significance. These are the 2 positions, this position on chromosome 6 and on chromosome 14. Those are what we identified back in 2018. Again, they're showing up as genetic markers for risk of Waldenstrom's. So with the new Waldenstrom's patients and controls, we're clearly validating what we found back in 2018. But what's exciting is that we're finding new positions for the first time to be associated with risk of Waldenstrom's. And there's one on chromosome 1, chromosome 2, there's more on chromosome 6, chromosome 9. So this is pretty exciting for a very rare malignancy. So in conclusions, families with multiple members with Waldenstrom's or other lymphoid malignancies contribute to finding genetic markers for risk of Waldenstrom's or these other lymphoid malignancies. For Waldenstrom's, we have 2 genetic markers that have been previously identified and that we have now further validated their risk for Waldenstrom's, but we have new genetic markers, around 20 or so, that we have identified with risk for Waldenstrom's. And so we are going to be evaluating how the polygenic risk score for these genetic markers for Waldenstrom's could help predict risk of Waldenstrom's among family members or just among individuals in the general population. Again, there's still no preventive measure. It would just be information for you to be informed about your potential risk for Waldenstrom's. So I would like to acknowledge all the study participants. I'm so grateful for contributing their time and biospecimens and filling out the questionnaires. I know it takes time and effort, and we couldn't do these studies without your contributions. And then all of my wonderful colleagues as well. So I can end there and take some questions.
Thank you, Dr. Slager, for this valuable information informing our global community today about the familial research you're conducting at Mayo Clinic. It was a fantastic presentation and really excited to hear about the previous markers that you had come across, plus the new genetic markers. Looking forward to finding out more information about those and see what comes down the pike in terms of additional things that can be done in that regard. So with the time remaining, Dr. Slager is going to answer as many questions as possible. Please be advised that Dr. Slager is a researcher and will be unable to answer personal clinical questions outside the topic of familial WM research. You can enter your questions in the question and answer tab on your screen. And I've seen some people have already placed their questions in there, so that's fantastic. And I participated in, and I noticed there's a question here, so I'll add some more to it. But yeah, you mentioned Dr. McMasters as a colleague of yours, and and I know she's retired, but I participated in that study. Is there any overlap between your study and hers, and how do you look at the patients in her study versus yours and decide that, oh, that's the same patient or not, or how does that work?
Yes. So Mary Lou, she McMasters is retired, and I'm sad to have her retire because we've been working together since 2004. So through genetics, you're able to identify who's related to whom because you share your genetic markers across your relatives. And so if you don't have any if you're not related to an individual, you don't really share that many of the genetic markers. And so that's how we know if the same individual participated in both studies. But I don't recall having too much of an overlap across our cohorts.
Okay, thank you. Someone asked the question if you need more study participants. I do want to mention, I forgot to mention that in that question and answer section, there's information on how to participate in the study. Please take a look at that. And we'll be sending some information out after this presentation is over on how to view the presentation, the recording of it, and we'll send that information out also. There's a question that I have WM, as does my son-in-law's father. So 2 of my granddaughter's grandparents have WM. How much higher would her risk be, or does that factor into it?
Let's see. Where is that question again?
That's probably like number, let's see.
Okay.
Number 18. Yeah. From Marcy.
Okay. No, it's not showing up on my. Okay, can you read the question again?
Yeah, I have WM, as does my son-in-law's father. So 2 grandparents have WM.
Son-in-law's father. Okay, so the son-in-law's
Yeah,
father and the individual. So you're talking about the children. Um, so it really would be the grandchildren of the individual,
right.
right?
Yeah,
That would have something from both sides of the. And so, it's hard. I don't know the familial risk by each type of relationship, but knowing that you have two members in the family that are contributing to the grandchildren risk of Waldenstrom's, I would probably say they have a good 16-fold increased risk of getting Waldenstrom's. But you were talking about grandchildren and not first degree relatives, but the risk would be elevated because it's coming from both sides of the family.
thank you. And then just to quote the statistics, like roughly 3 in a million people contract WM. So a
Mhm.
16-fold increase would mean 48 in a million. So it's still very
It's still
rare, but
rare.
it's just an increased chance of
Yeah.
getting it. Yes.
Yeah,
Okay.
exactly.
So another question, there's no history of WM lymphoma in my family. Now that I have it, it's kind of related to that. Is there a chance that my children or grandchildren could develop this? Should they be tested for it?
Yeah, so as we kind of went through, they do have a elevated risk of getting Waldenstrom's, although it's still a rare chance of them getting it, but they're more than the general population. Should you get them tested? This is a personal, right now it's a personal choice, because if you get tested, there's still nothing you can do about it. There's no amount of physical activity, yoga, diet, medicine that you can do to prevent it that we're aware of right at the moment for increasing your risk or for reducing your risk of getting Waldenstrom's, even though if your genetic markers suggest that you have an elevated risk. So it's really a decision of, do you want to know? And maybe in the future, we'll be able to do something about it. But right at the moment, it would just be information about your risk. But, some people, when I ask people, just the general population, say when I get my nails done or get my hair cut, I ask the individuals how they would feel, and everyone answers differently. But if you did the genetic testing and you're at the low end of the distribution, like the first quintile that I talked about, you're actually protective. Your risk is really low, and maybe that would make you feel better. But if you're at the high end, then you have an increased risk, and then that may cause anxiety, and maybe you don't want to know that. So again, it's a really personal decision that somebody has to make at this time until we develop some sort of preventive measures for reducing your risk of getting Waldenstrom's.
The uh, so for you mentioned the newer genetic markers. Any idea when that information is going to be published, or what we look for in terms of timing of that?
Oh, good question. I really hope we can get this out submitted by as soon as possible, but I'm guessing early summer, early June is when we would submit this. I'm hoping we can present this at the American Society of Hematology in December. And so an abstract, I'm hoping we can get an abstract. Those abstracts are due in August, I believe. So we can actually start presenting it, but maybe it would be published before then, depending on how quick everything is. But I have a feeling that we'll submit the paper in the next 2 months or so.
Great, we're looking forward to that. And another question here is with regards to testing, like where should someone go to get blood tested, or what kind of blood tests are done for that?
Yeah, good question. Um, well, I have a feeling there's these companies that like to do genetic testing. Based on the work that I've done, and they develop these scores. So do I advertise for them? I don't know how well they do it. Um, that's a good question. and I don't really have. So there's companies that would do it, and you pay money to get it done. It's not in the clinical practice right now, in part because there's nothing to do about the risk. Can I give it through a research? I would have to modify my protocol to then share the results. And we're in discussions about doing things like that, sharing more information about what we learned about your risk. And so we're trying to figure out how to convey this information. And boy, I really, if you want to contact me and share me your thoughts, but part of it is education. I can give you a number of your risk, but the interpretation of that number needs to be developed so everybody can understand what it means and not misconstrue it and stuff like that. So we're developing educational opportunities. Do we do it through a venue like this? Because of COVID, we're used to having these video conferences now and having more educational sessions through this. Do we do it through a brochure and here's your number and here's a brochure and documentation about what it means? Is that the best way to share this information? That's what we're kind of working through. And I'm happy to hear your thoughts or email me your thoughts about how to share information.
Thank you. Hopefully you'll get some responses from the people that ask those questions.
Right.
And it is a personal decision as to whether to get your children or tested or not, and especially when you're not certain if there's anything you can do about it anyhow.
Ask yourself, do you want to know?
Yes.
Like I said,
Right.
Everyone has a different opinion. So.
Right.
Someone asked, is Mugus genetic? Should I get genetic? Mugus is genetic. Mugus is associated with, if you have Mugus, you have an increased risk of getting Waldenstrom's. Again, there's nothing you can do about it. But Mugus is a cancer, or it's not a cancer, it's pre-cancer condition. There are more treatments in development for preventive progression for multiple myeloma, and I don't know if it actually prevents from Waldenstrom's yet, but more work is being done in research for MGUS, doing genetic testing, but there's not as many genetic variants have been identified for MGUS. I'm working with my colleagues here at Mayo Clinic, and we're about to conduct our genetic studies for MGUS. And so we'll know more by the third quarter of the year. So we'll have quite a large number of MGUS patients enrolled.
Well, that kind of leads me to ask my question, and I wasn't sure to ask it yet, but I have Waldenstrom's, and my wife has monoclonal gammopathy of renal significance. Should that be of concern with regards to our children and grandchildren?
Again, they would have elevated risk, yes, for these malignancies, including multiple myeloma. And the genetic testing would be less clear because you're talking about Mugus, which tends to go on to myeloma as opposed to, Waldenstrom's is part of that spectrum. The genetic variants for Waldenstrom's, I don't think overlap with multiple myeloma. And then I don't think they overlap with MGUS right at the, there's only 2 for Waldenstrom's that we've published. And then I haven't looked with the novel ones to see if they overlap with MGUS, but that's a good question. And I think something we can add to the paper to see what the overlap of the genetic variants for myeloma or MGUS for the Waldenstrom studies. So good questions. Keep asking them, and then it'll help us with our research.
Okay. I'll definitely sign up for the study if I qualify. But The let's see. Another question, if and this is sort of a other type of cancer. So if my mother had a rare thyroid cancer, could that have something to do with why I have Waldenstrom's?
Um, that one, I don't think so. Um, I don't think that there's a connection between having thyroid cancer and then an offspring going on to having Waldenstrom's. But like I said, Waldenstrom's really rare. And seeing that, and thyroid cancer is not exactly one of the common cancers like colon and breast cancer. Those are the more common ones. And so looking at that relationship between the two would be hard to study. So right at the moment, I don't recall a connection between thyroid and Waldenstrom's.
Okay. And kind of related to that, but you mentioned that you have roughly like 1,600 WM patients in the studies and 59,000 controls. In your controls, are those healthy individuals or do they have other types of cancer? Or maybe I missed that.
They do. Well, healthy is all relative, but they don't
Yes.
have they don't have any hematological malignancy. But to be in the study, you could have another cancer, or you could have cardiovascular disease because they are adults over the age of 60 typically, and so we all have conditions, autoimmune, cardiovascular, diabetes, obesity. And so, healthy is not exactly true. They're just individuals without a lymphoid malignancy or a myeloid malignancy.
Okay. That's okay.
They're
That
not the
helps
super, super
clarify.
healthy
Thank you.
people with nothing.
Okay. That's what I was wondering. Okay. Thank you.
Yeah. Yeah.
Um, and, with regards to looking at that genetic linkage or uh, predisposition, let's say, based on what your parents or grandparents had. And I think you mentioned this in your when you were going through your presentation that it's kind of difficult to see if maybe it's passed on from the female gene rather than from the mother rather than from the father or vice versa. Is that true, or is that part of your study also?
We haven't looked at the genes as much that fall on the X chromosome,
X or Y.
or the
Yeah.
Y chromosome. That is in our list of to do things. Across most of the lymphoid malignancies, they tend to show up more in males than they do in females, which suggests that maybe there's some sort of factor related to sex that increases your risk of these lymphoid malignancies. But to be honest, we haven't figured it out yet why that's the case. And looking at the genetic markers on the X or the Y chromosomes, just remind everybody, if you're a male, you have a Y chromosome, and if you're female, you don't. You have two X chromosomes. And is there something on the Y chromosome that are increasing the risk for these lymphoid malignancies? We're not seeing it. It's not prominent. I mean, it's been looked at, but it's not showing up prominent.
Um, and if someone is to participate in your study, would they receive any results or reports or feedback from that participation?
Good question. And right now, the answer is no, in part because these are not clinical tests and we're not allowed to share these informations. And that's the consent that we don't share these informations. But as I mentioned earlier, we are looking to do that, and we're trying to figure out how to do that. How do we share the information? I mean, do we just mail you a letter and here's your results and good luck and go to your doctor? That's not the ideal situation, because most of the time your doctor, especially your primary care physician, won't know the interpretation of these results, and they don't have time to go through that. But we would really like to sit down and do that. But with with thousands of patients, we're not able to do that on a one-on-one basis. So we have these webinars and everybody comes in with their results, or do we just mail you with a interpretation of your results? Again, we are actively looking at that, but we don't have the protocol in place to do it. And so if we were going to do it, we would have to reconsent people to get the information back. We couldn't use our prior study at this time because you would have to consent to say, yes, I want the results back. I would have to know that to share the results. But because they're not clinically actionable, we don't share the results. If we find something that, yes, it is clinically, something can be done, we're automatically required to share the results. Does that make sense what I'm saying?
Yes. Yes.
Yeah. If you're at increased risk of getting a disease and we see it and there's something that can be done about it, we will tell you. But right now, these genetic markers that we found, there's nothing that can be done about it. So right now, we don't share those results.
Okay. Thank you. Yes. And for those of you that are out there, of course, if there are published articles about these research studies and whatever, you can be assured that at the IWMF, we'll do our best to make that information available to you. We try and educate everyone as much as we can. And of course, we could have Dr. Slager and others at future ed forums to talk about their amazing findings and share them with us. And I had a question here. It just disappeared. With regards to, if you look at certain families and the patterns, like, is there a reason maybe why one family may have the Waldenström's and CLL and whatever among all the children, and others may have just one of them? Is there any way to look at the rhyme or reason behind that? Is it genetics? Is it environment? Is it who knows what?
Well, I would say genetics has a strong reason of what behind that, the difference. Less so with the environment, but environment does have a role in these lymphoid malignancies for Waldenström's and for CLL or other lymphoid malignancies, but it's not as strong as what it is for genetics. So I would say the difference would be your genetic makeup across those families.
Okay, thank you. Let's see. Yeah, you've covered a lot of these questions. They have covered similar topics. I'm trying to get to all of them because I want us to be able to address as many questions as we can. Currently, like a lot of people, when they talk about the topic of familial WM, and it gets them to start to be concerned about their children and grandchildren, like, should they tell their children and grandchildren, well, I have WM, and there's studies out there that show that you have a increased risk of getting WM just by the fact that I have it. Should we tell them or not? Or is that a personal decision? Or
should you tell them that you have Waldenström's?
Well, they may know you have Waldenström's, but tell them that because you have Waldenström's, they have an increased risk of getting it themselves, potentially.
I think I would be telling them, but that again is a personal decision about what you share or having that conversation. I guess if you have hypertension, do you have the conversation with your children about their increased risk of hypertension? There's some genetics to that. I guess, for Waldenström's, it's a strong increased risk, and I guess I would have that conversation with my kids.
Thank you. There's a question here about genetic lineage, let's say, and there's been some studies that have pointed to a lot of WM patients that have had Ashkenazi Jewish ancestry. I don't know if you noticed that in your studies of your familial studies, if that has popped up at all as a precursor, let's say, to the majority of WM patients or not.
Yeah, so the question, for breast cancer, having Ashkenazi's Jewish background, you do have an increased risk of some of the BRCA1 and 2 mutations that definitely increase your risk of getting breast cancer. Now, as far as the lymphoid malignancies, we haven't seen it as predominantly as you see it in breast cancer. But it really has to do with the genetic makeup, not so much the culture, the Jewish culture per se, but it's the genetic makeup of the Ashkenazi Jewish culture that increases your risk for getting breast cancer. But for lymphoid malignancies, it's more rare tumor, and so it's harder to study something like that. But my colleague from Israel, Geffen Kleinstern, I know we're working together. She has a cohort of individuals that are Jewish and of Arab descent, and we do see differences for the genetic makeup for diffuse large B-cell, which is a lymphoid malignancy, and follicular lymphoma. We haven't looked for Waldenstrom's in that study yet. But we do see some genetic differences, but they're not strong. They're not that strong.
Thank you. About close to the end of the hour here, so I have time for one more question. And this one's kind of interesting. It's my grandfather, my dad, and myself had WM. My grandfather was diagnosed around 68, my father around 48, and myself at 48. In your research, are you seeing that in familial WM, that the newer, younger generations are getting diagnosed at an earlier age than the older generations, let's say maybe 20 years ago or whatever?
I think we're just better at it than we were. So I think there's a big change, a big reason for the earlier age in the younger generations than in the grandfather generation is because we just know more about the condition. We know how to test for it. The tests are easier are done. I think that's a major factor rather than earlier age of onset for Waldenstrom's.
Thank you. Yes, and that's just about wraps things up. But yeah, the efforts by you with regards to the familial research you're doing and other researchers have contributed tremendously to helping us know more about our disease. So we definitely appreciate everything you do on our behalf. And I encourage everyone to, if they have the opportunity, to participate in the study. The more of us that participate, the better information we have and the better treatments we'll have in the future for all of us. So thank you again, Dr. Slager, and to our audience for your participation. Please participate or complete the survey that's going to pop up on your screen once the program ends. And remember that this week on April 17th, we'll be recognizing WM World Awareness Day. It's the first time we're doing that. So we hope you can help us raise awareness about WM within your networks. In addition, our annual Ed Forum is going to take place on May 3rd through the 5th in Renton. The event's going to be available virtually if you haven't registered already, if you can't attend in person. For more information, go to our website at www.iwmf.com. Thank you again, Dr. Slager. This was a very informative study and really looking forward to the publications are going to be coming out and further results that you find and your findings. Again, fantastic work, and thank you.
Thank you.
So
thank
everyone, stay safe, stay healthy, and stay Waldenstrom.
Bye-bye.